Hello guys, how are you? I think everybody is fine. So let's start today the NLP. So basically today we are starting the NLP. Here we will learn all of these things like how to convert word into vectors and embedding all of these things like what is RNN, LSTM, transformer, ChatGPT, BERT. Everything we will learn from basics to advanced. So today is the day one and let's start our NLP. Basically, NLP is the best thing to learn if you want to be a data analyst or a machine learning engineer or a deep learning engineer. So let's start our journey to learn the NLP. NLP means natural language processing. So here is the NLP course. So LSTM NLP for machine learning. Yeah, this is the playlist that we have to follow. So today is the lecture one. Let's start from beginning. So in NLP basically this is from one hot encoding. Basically I have to find where I have to start. This is not LSTM RNN, RSTM practical is there. Okay, so I think here we have to start. We have not the previous lesson. So let's discuss what is NLP and how to learn NLP and what is text pre-processing, all of these things. So basically, if we want some, you have seen nowadays ChatGPT is famous. So behind the ChatGPT, the NLP is working. So NLP is basically a process where we have to learn all of these things like how ChatGPT is built and how to build your own ChatGPT. Basically, we will learn. So before to learn ChatGPT is basically a hard problem. So basically, we will start from initial like how ChatGPT works. Like suppose show we will pass our input as a English, but we know that ChatGPT can't understand English, so we have to convert this English sentence into embeddings, and then embedding is basically a math representation of this word. Suppose you are passing my name is something, then this my name is something will have some meaning in math. So we have to convert this into math, and then computer basically understand 0 and 1. So basically this will can understand embeddings. So we have to convert this NLP into embeddings. So now we will learn how to convert all of these things. So begin with this process, we will learn what we have to do. Suppose you have to do a simple project like email classification. So for email classification basically uh, this is a simple process where we have to classify this is a spam or not. So to describe this is a spam or not a spam, basically you don't have to focus of the previous and context, but basically the context is not required in this sentence. If you do some deep learning process like NLP related context based classification, then it will give a higher accuracy corresponding to the traditional learning algorithm. So basically we are firstly try to implement a traditional deep learning algorithm like linear logistic regression and find the accuracy, and if we get a good accuracy, then mm, why we need a deep learning. So we will learn like how and why. So like a simple algo project like spam classification and some, here we can apply a traditional machine learning algorithm. But suppose you want to do a translation from English to Hindi and some other language, then there this traditional machine learning algorithm will not work because they are not able to capture the context of the meaning. Suppose you are talking the bull is going. So the bull is going. Basically, you can't understand. I say bull is going. Now you are not able to understand like animal is going, or we are talking about animal or a stock market. If I say bull is going high, then you are able to, he's talking about stock market. That's why. So to understand this context of a meaning, basically we convert into embedding, and then we'll create a transformer like word model, so that they can understand the context of this meaning. But in traditional, we can't able to capture the context of the words. So let's start our topic NLP. Previously, I am giving the introduction like of this. So to begin this NLP, basically, wait 1 minute. I will check if there is any other playlist is there. Complete statics, ML project, Python resume, complete deep learning, statistics, ML project. Okay, so there is not there text generation. Okay, so let's start our text preprocessing. Firstly, before purpose preprocessing, we will learn like what what we have to learn. So we have to know like what is tokenization, lowering the word, regularization, stemming, lemmatization, and some stop word. What is this? So tokenization simple means we have to convert our birds into tokens. Suppose you will get a bird like my name is Narendra, then you have to convert into token. So in token is basically your birds. Basically my is one token and name is other token, something like that. Token is basically your different birds. And suppose you are doing a sentiment analysis, then you have to firstly tokenize your word, and after tokenization you have to lowercase the word. Lowercase you have to do like, suppose in your sentence two times some word coming in and all, like he firstly have written T, capital T, like the in capital T and another small t, then they can like machine learning will understand this is a different word. So we have to lowercase the word so that they can understand, yeah, this is the same. And regular expression we have to apply, so that we can get only English and math word, and some like comma and these are will be neglected. And now what is stemming, lemmatization, and so basically we will get our data, and then we have to give a text preprocessing. In text preprocessing we have to apply tokenization, lower indicators, and regular expression. In this second step we have to text preprocessing is there. So in text preprocessing basically we have to apply a stemming, lemmatization, and stop words. So in stemming basically there's two two types of stemming and lemmatization is there. So stemming we will get a stem, any root word of that word. Suppose there's a word like history, then you will get a like. Suppose there are three words: history, historical, and history, something like that. So then you will get a stem. Stem is basically a root word of that word. And lemmatization is also a stemming process, where you will get a good accuracy according to stemming. In stemming basically you will get a root word, but stemming in lemmatization we have to lemmatize this word. So lemmatize will give a good, basically a meaningful answer in respect to stemming. So that's for stemming and lemmatization. And we have to also apply stop words. So like if you're doing a sentiment analysis, then is there is no meaning, so we have to also apply stop words. But we know that in the stop words, in the analytical library, stop word is present, like no is present in the stop words. So if you are doing some like thing sentiment, and there may be some problem sometime will be created. Suppose I will give you some money and I will not give you some money. There's a opposite difference. But if you apply stop word, then the meaning will be same. So that's why if sometime we have to apply a stop word, or you can also create your own step words, basically a dictionary, and then apply it. So that's for stop words. Now start our, this is the basically previous basics of this basically we are learning. Now I start our text preprocessing. So that's we have learned. And sentiment analysis. Suppose you have a these are your document means basically yes, data point d1 d2 like rows in your data set. The food is good, this is a positive sentiment. This the food is bad, this is a negative sentence. Pizza is amazing, good sentence. Burger is bad, this is a negative sentence. So these are, suppose your input and output is there, so like what we have to do. So firstly, we know that our computer can't understand the English, so we have to apply some algorithms so that we can convert our text into vectors. So vectors, now we have a vector. This is basically we have different types of vector like one hot encoding, back of bird, TF-IDF, and bird to back, average bird to back. These are some different types of, basically we can say vectors representation in machine learning, so that we can pass this vectors to our ML model. So ML model can learn according to this vectors. So now learn what is one hot and we will learn all of these representation in text into vectors. So firstly we will start from one hot encoding, and then we will learn back of bird, TF-IDF, bird to back, average wise to back. Basically these are one hot encoding, and back of bird is the previous basically starting algorithm where scientists have researched, but they are not getting good accuracy after they have research, like mm, research, or we can say discovered TF-IDF where we will get a good accuracy according to like s- respect to back of birds, and then they have find a bird to back, which is also a very good. Basically nowadays we are using a bird to back, or we can say average bird to back, and there's a small difference in bird to back and average bird to back we will learn. So now start one hot encoding. So basically in one hot encoding we will give one value to that text, basically we can say. So basically the name suggests that like one hot encoding we have to give one to this encoding. So now suppose you have a sentence, the food is good, the food is bad, pizza is good, burger is bad. So in suppose we have a three data set d1 d2 d3. So then we have to give a corresponding number to every bird, like we have give the a unique number and food to a unique number and is a unique number. So suppose this is your vocabulary, we can say the food is good, bad, pizza, amazing. So for we have to create a unique dictionary, unique bird dictionary, basically unique bird dictionary from your training data set, and give a unique number to that bird. And then for apply one hot encoding, basically there's libraries there. So we will give where is the present. Now we have to give one here, one to that point, and everything will be a zero. So basically this is known as one hot encoding. Suppose you are creating a vector for the, so for the is it is one and everything is zero. And suppose you are creating a like one hot encoding vector for food, then food is one and everything is zero. That's how we will create a one hot encoding vector. So you have a four like length vector this na, and so and the your vocabulary size is 7, so your output matrix will be a 4 cross 7. That's you can see like this. Here the food is good is represented like this, and the d2 vector here you can see the food and is, and the bad is represented like this. So d2 vector and d3 vector something like that we have to represent it. Mhm. One hot encoding. Yeah, so basically now understand what is one hot encoding. So suppose at the time of training you will get different birds. So you have to firstly find the unique bird in your training data set, and then give a unique number corresponding, like you have given the one number, then in food you have to give a second number. it is giving a three number. So like you have to give a different numbers to every word. And at the time of creating a one-hot encoding vector of that word, so the position of that word is one and everything rest will be a zero. That's how we will create a one-hot encoding vector of that word. So like what is advantage, and now we will learn a disadvantages of that one-hot encoding. So advantage is basically it is simple and intuitive. This is the only one advantages in one-hot encoding. And disadvantages, so basically it's a huge sparse matrix, sparsity is there basically. And the other disadvantage is like, oh, it is overfitted. Overfitting means in your data set everything is zero and only one is there. So this may sometimes be overfitted because everything is zero. So suppose your model will learn like, yeah, I have to predict it only zero, so now it is predicting every time a zero. This may be a possible outcome. And fixed size input, yeah, this is also a problem. So suppose you have a different, like here you will get a 3 cross 7 matrix and here you will get a 4 cross 7 matrix. This is also a disadvantage. Like suppose you have a different 50k vocabulary size, then how sparse matrix you will create, you can even not think. Like your model will be very huge. It will not recommend like use this type of one hot encoding. Don't apply. If you will get a very big data, then do not apply this one hot encoding. And out of vocabulary is there. Suppose in your training data set king is not there, but if you are providing a king at the test data, this is maybe also a possible case. So your model will can't understand now what is king. So this also a problem. Or no semantic meaning is getting captured. Yeah, this is also a problem. Like your vector, basically this is a vector representation. So food is represented by 100 and pizza is represented by 010 vector, and burger is represented by 001 vector. So if you create something like this vector, then there will be a very huge difference. So also the semantic meaning is not captured. So we have to apply some encoding so that we can get a semantic meaning basically. So in word to bag we have this feature so we can get a semantic meaning. Let's start our second bag of birds, like how to create bag of birds, and some now discuss our bag of birds. So these are some advantages. So basically advantage is only one, it is simple and intuitive, but disadvantage is more like a sparse matrix, which is the biggest problem is sparse matrix. And out of vocabulary, no semantic meaning capture, these are basically a very huge problems in the NLP. So they have, the scientists have now researched a bag of birds. So basically in bag of bird they have create a bag. Suppose, so bag is basically a bag where you have some birds inside a bag. Now learn. Here basically the problem is also a the input is not a fixed size, but here we have create a bag of birds so that we can get a fixed size vector. Hmm. So in this basically, suppose we have sentence like a document, or we can say a row D1 D2 D3, then firstly we have to apply a stemming lemmatization stop bar we will apply, suppose, and lower the all the case, and then we will get S1 equal to good boy, good boy, good girl, good girl, boy, girl, good, something like that. And basically this is also a sentimental answer. So what we have to do, firstly we have to calculate the frequency of that word, and then according to this, if the sentence, inside the sentence, suppose firstly we have to create this a unique bird dictionary. And if you are creating a sparse matrix for, or we can say a bag of bird matrix or a vector we can say for this document, then you have to give one to that position and rest everything will be zero. So suppose your sentence one is good boy, so good and boy will be one and rest everything will be zero. And so for this boy also it's same like good girl, good boy, girl. So your output will be some according to your input will be there. So suppose your frequency some bird in a sentence like there's suppose maybe possibly you have a sentence. My name is Naren Singh Nangi and I am a teacher in machine learning. So maybe suppose two time a bird is repeating, so your frequency will be two. Or maybe according to that, so we have to calculate the frequency and then write the frequency here, like how many times this will be presenting. Also we have a binary bag of bird is there, so here we will get only 0 and 1. If the frequency not present, then it will be 0. If it is greater than 1, it will be 1 only. So we have to apply count will be get updated based on frequency basically. So for this is that, good boy girl. And now coming to this advantage and disadvantages of whack of hearts. So the advantages is basically it is also a simple and intuitive. And now one problem we have solved which was held in one hot encoding, which is basically a fixed size. Now we have a fixed size vector every time. Suppose you have a different unique words in your dictionary is 500, then you will get a 500 fixed size input every time. This will basically depend on your input like unique words in the dictionary. So this known as bag of birds. And now discuss the disadvantages. Sparse matrix now is also there. It is reduced somewhat, but it is still there. Suppose your dictionary have a unique, your training data set will have a 50k unique, but then suppose every document you will get a 50k length. This is again a very time complexity or we can space complexity problem is there. So now this is problem. The second is semantic meaning is again now not captured. Suppose your vector has the food is good and the food is not good. So basically node will be, suppose you have also capturing a node, but again you will get a similar matrix like this and this may be more similar, but the meaning of this both sentence is opposite. So that's why you are not getting a semantic meaning also. And out of vocabulary also exists now. Suppose in your training data set again some word is not there, but in testing it will came, so you can't know like which word what is the meaning of that word. So again the out of vocabulary is also exist. Order of the word is getting captured. Yeah, order of the word is getting changed means order of the word is getting changed. Yeah, so you have given this means basically you have create a dictionary and give a random number, and suppose at the time of creating this document you the bird may be coming from first and second, like there may be some random every, like you have written a first message like my name is Naren and you in the second Naren is my name, then the ordering of bird is different, the meaning is same. So your model will now can't understand this. So this is again a problem, like ordering of bird is getting changed. So this is the problem. But in this we have something like n-grams, also bigram, trigrams basically. So in bigram and trigram we will take a two bird at a time or three. Like you are doing a bigram, then we will take a two bird at a time and give a third bird. Basically we will also combine two bird at a time. So like suppose you have a the food is good, the and food is or combined in a bun dog bird, and food is also a bun bird and it's good is also a bun bird. Now we have doing something like that so that we can get a good accuracy. And suppose sometimes a bird is coming repeated like my name is also like in every sentence name after name is will came. So that's why we have to bigram and trigram Brilberg very fine. So we have unigram, bigram, trigram, bigram and trigram is there. So this is the advantage and disadvantage of bag of birds. Now let's start our TF-IDF. Okay, now we TF-IDF we will see in the next lecture. Thank you guys for this attending the first NLP basically lecture. Now we will meet in the next lecture where we will learn the TF-IDF and like bag of bird. BF bag of bird is done like word to bag and average word to bag. These terms like converting a bird into vector, this algorithm is very best. You have to know this algorithm. If you apply this algorithm, you will get a good accuracy. TF-IDF is somewhat good than one hot encoding or basically bag of bird, but it is not comparable to uh, basically bird to bag. Let's see TF-IDF in the next lecture. Thank you guys. Meet in next lecture. Please subscribe my channel to get a good content like this. Now I am teaching you a very fast way, but sure I will start from basics and to go to advanced. After 1 week, after completing the NLP, we will start from basics. Thank you guys. Bye bye. Love you. Meet in the next lecture.